Hi everyone, this lesson is about integers. Integers are basically whole numbers. We'll get into that in a minute. And we're just going to be talking about integers in general, kind of how they behave, different types of integers, positive, negative, even, odd, how they divide into each other, how they multiply to each other, and all kind of interact. Okay, so let's just jump in. First of all, that definition of an integer. I said it's a whole number. You can think of it as a whole number, a counting number, 1, 2, 3, 4, 5, the regular numbers, except we're going to include the 0 and the negatives. So technically, whole numbers don't include the negatives. Integers do. So let me give you an idea of what that's going to look like. So I'll just randomly start at -4, -3, -2, -1, 0, 1, 2, 3, 4, ... So etc. So integers do not include the numbers in between, like 1.6 or 3.5 or decimals and fractions. Okay, so that's integers, the definition. Now let's talk first about multiplying and dividing integers, and specifically with regard to their sign, whether they're negative or positive. So let me bring that negative positive back up. So you may be used to multiplying and dividing positives by each other. So for instance, a positive 3 times a positive 2 is a positive 6. So a positive times a positive is a positive. Also, a positive divided by a positive is a positive. You may remember that. A 10 divided by a 5, positive 10, positive 5, is positive 2. Now, it's also true that a negative times a negative turns out to be a positive. So for instance, a -3 times a -2 is also a positive 6. And a -10 divided by a -5 is a positive 2. I'm sometimes putting plus signs and sometimes I'm not, because normally we don't write plus signs, right? So 6 is just positive 6. So what's the lesson here? This is a negative times a negative. This is a negative divided by a negative. The lesson there is that if you have the same sign and you're multiplying or dividing, you always get a positive number. Think of it as the same types of things get along in a positive way. So let me write that down. So same sign, you get a positive answer. So a positive, we'll do times with parentheses this time. A positive times a positive equals a positive. And a positive divided by a positive also gives us a positive. Again, same sign. Same with negatives. A negative times a negative is a positive, and a negative divided by a negative is a positive. Same sign, you get a positive. Different signs result in negative numbers. So for instance, a -7 times a a positive 5, is a -35. Different signs. And of course, it doesn't matter what order. I could do the positive first, like a positive 2 times a -6, and I'd get a -12. Okay, same with dividing. A -24 divided by a positive 3 is a -8. And it doesn't matter if the positive is on top. So for instance, positive 20 divided by -4 is a -5. Okay, so lesson there. Different signs, when you multiply or divide, you get a negative. So let's write that down. Different signs give you a negative number. So a positive times a negative is a negative, and or negative times a positive. And a negative divided by a positive, or a positive divided by a negative, is also a negative. All right, now let's talk about something called divisibility rules. This is going to be, well, let's clear some space. This is going to be looking at a number and quickly deciding what numbers divide into it. So for instance, someone gives you the number 536, and you want to know, does 2 go into it, does 3 go into it, 4, 5, 6, 7, and usually we go up to about 11 for divisibility rules. So let's talk about them for the first few positive integers. So 1, of course, goes into everything. And now what about 2? 2 goes into any number that's even, which means the number ends in a 0. Let's write this down. The number ends in a 0, a 2, a 4, a 6, or an 8. Any number that ends in those numbers is an even number, and 2 will go into it. So does 2 go into this? Yes. Does 2 go into 3,275,861? No, because it ends in a 1, which is not in our list. Now the rule for 3, the divisibility rule for 3, is interesting. It's if the digits in the number add up to a number that's divisible by 3. So for instance, well, let's look at 5 plus 3, this number. We add up the digits. 5 plus 3 is 8. 8 plus 6 is 14. And 3 does not go into 14. So 3 does not go into that number. All right, let me move this number over. So if digits add to a number divisible by 3, let's look at one that works. Take the number 291. Well, 2 plus 9 is 11 plus 1 is 12, and 3 does go into 12, so 3 does go into 291. Interesting little rule. The rule for 4 is if 4 goes into the last 2 digits. So for instance, 9,324, you only have to look at the last 2 digits for 4. And 4 does go into 24. It goes in 6 times, so 4 definitely goes into the whole number. Now, of course, 4 can only go into a number if 2 goes into it. So if you had, let's say, 106,973, you wouldn't even bother to see if 4 goes in because it's not an even number. 2 does not go into it. Therefore, 4 cannot go into it. So does 4 go into our first number, 536? Yeah, because 4 goes into 36. How about 5? 5 is simple. It's if the number ends in a 0 or a 5. So it's all there is to it. Let's say 750. Yep, ends in a 0. 8,392. Nope, doesn't end in a 0 or a 5. How about 96,285? Yes, it ends in a 5. Okay, the rule for 6. This is a new one, a different type of rule. It's basically, not basically, it is if 2 and 3 go into the number. So since 2 times 3 is 6, if you want to check for 6, you just check for 2 and 3 and make sure they both work. So let's try it. Let's go 792. 2 goes into it because it's an even number. It ends in a 2. All right, now we check for 3. 7 plus 9 is 16. 16 plus 2 is 18. Yes, since 3 goes into 18, 3 goes into 792. Therefore, 6 goes into 792. Okay, let's jump up to 8 now. The divisibility rule for 8. The one for 8 is similar to 4, but it's if 8 goes into the last 3 digits. And by the way, there is a divisibility rule for 7, but it's kind of complicated, so it's not that helpful. You can just try dividing 7 into a number to see if it goes in. All right, so last 3 digits must be divisible by 8. For example, 274,400. 8 goes into 450 times, so therefore 8 will go into the whole number. All right, let's do 9. The rule for 9 is just like 3. If the digits add to a number divisible by 9. So let's try that out on 536. 5 plus 3 is 8. 8 plus 6 is 14. 9 does not go into 14, so 9 will not go into that number. Let's try another one. Let's try 477. Well, 4 plus 7 is 11. 11 plus 7 is 18. 9 goes into 18, so 9 goes into 477. All right, the rule for 10 is if the last digit is a 0, so 7,370, yes, 10 goes into that. And the last one we're going to look at is 11. 11 is really interesting. A number is divisible by 11 if the sum of the odd numbered place digits minus the sum of the even numbered place digits, even numbered place digits, is divisible by 11. So that's kind of a mouthful. Let's see how it works out. Let's see how it works with the number 10,538. So the odd numbered place digits are the first, the third, and the fifth. And then the even numbers are the second and the fourth. Those are the even numbered place digits. So we add the odd number. 1 and 5 is 6 and 8 is 14. And we subtract the sum of the even numbered place digits, 0 and 3, which is 3, and we get 11. And since 11 goes into 11, 11 also goes into this number. Pretty cool. So those are some divisibility rules. They can be very helpful when you're, for instance, trying to simplify some fractions. You've got 236 over 912, and you want to know maybe how you can simplify that, what numbers go into both. You can rule certain ones out and figure others out. So very helpful. For instance, I can see that 4 has to go into both numbers because 4 goes into 36 and 4 goes into 12. So I could divide by 4. I wouldn't divide by 3 because I can see that 6 and 3 is 9 and 2 is 11. 2 and 1 is 3. 3 and 9 is 12. So yes, 3 goes into the bottom, but 3 doesn't go into the top. Okay, let's move on. The next thing we're going to talk about is consecutive integers. Consecutive. And consecutive just means one after another. So if I said 3 consecutive integers, that could mean 7, 8, 9. I just happened to start at 7, and then I did one after that, one after that. So that's what consecutive means, one after another. And you could start anywhere. What happens if I started at a negative number? Say I started at negative 12 and I wanted the next consecutive integer, it would actually be negative 11. So it looks like you're going down, but you're actually going up because you're moving to the right. So we are moving to the right when we talk about consecutive. So negative 12, negative 11, negative 10, that would be 3 consecutive integers. Doesn't have to be 3. I could do 4 consecutive starting there. Okay, so we could also have consecutive odd integers. I could just put the word odd right there. And now it would look like this. Say I started at the odd number 13. The next or consecutive odd integer would be 15. Notice I'm counting by twos for odd numbers. 17, 19, 21, etc. So there's an example of 5 consecutive odd integers starting at 13, which I randomly picked. We could have consecutive even integers, in which case I'd be starting at an even number. Let's just take 46 as a random example. The next consecutive even, I'll put even up here, even integer would be 48, 50, 52, and so on. Notice again I'm counting by twos for even integers. And for both even or odd, you could also be in the negatives. So I could start at a negative odd number of 11, say, and these would now be my consecutive odd integers. Or I could start at negative 20, and these would be my consecutive even integers. I can also have consecutive multiples. What does that mean? Well, I could have, for instance, consecutive multiples of 5. That would just mean counting by 5s, basically. And if I wanted to start at 5, I could say 5, 10, 15, 20, and so on. So each of these numbers is a multiple of 5. So I'm counting by multiples of 5, or you could just say counting by 5. And we could start at 0 if we wanted to, or we could start at 115 if we wanted to. And then I'd go 120, etc. So you can count by any multiple of a number. I could count by multiples of 3. Starting at 0, that would be 0, 3, 6, 9. Okay? So that's consecutive multiples. Now let's talk about some rules for adding and subtracting even and odd numbers. Let's just take a couple odd numbers. Let's take 7 and 9, and let's add them together. We're going to get 16. Let's take two other odd numbers, 3 and 5. We add them together, we get 8. Let's just do it one more time. Let's take 21 plus 9. We get 30. Notice that every time I add two odd numbers, I always get an even number. So addition rules for that particular case, or subtraction, we're going to do that as well, is that an odd, we just saw, plus an odd will always equal an even. What about an even plus an even? Well, let's just try an example. 4 plus 2, 6. 12 plus 14, 26. So it seems like when we add two even numbers, we get an even as well. So even plus even is even. Okay, what about an even plus an odd? Let's try 8 plus 7. 15, that's odd. How about 11, that's an odd, plus an even, let's say 10, 21, another odd. It looks like when we add an even number plus an odd number, we always get odd numbers. And of course, addition, it doesn't matter what order we do this in, so even plus odd is the same as odd plus even, and we always get odd. Now, it turns out subtraction rules are exactly the same, except with subtraction. And I'll just do one example for these. So if we did an odd minus an odd, we expect to get an even, right? Because I told you it's the same as adding rules. So let's say 13 minus 7, yep, we get a 6. And then an even minus an even, we also always get an even number. So 22 minus 8, that's going to be 14. So that's even. And finally, when we get an even minus an odd, or an odd minus an even, for example, 20 minus 7, we get 13. Even minus odd, odd. Again, just like an even plus an odd. And again, just to be clear, the order doesn't matter in terms of even odds here. If it's an odd minus an even, you'd also get an odd. So to sum up, if the two numbers are different from each other, so one even and one odd, one even and one odd, the result is an odd, whether adding or subtracting. But if the numbers are the same as each other in terms of even or odd plus an odd, even plus an even minus even, and odd minus odd, you always get an even number. How about instead of subtracting or adding, we look at multiplying and dividing? Will there be rules for even, odd for multiplying and dividing? Let's look at multiplying first. So multiplication rules for even, odd. Let's just try an example. Let's try an even times an even. So 4 times a 6, we get 24. That's also even. How about 10 times 2? That's two even numbers. We get another even. And that pattern is going to continue. So an even times an even will always give us an even. What about an even times an odd? Let's try 4 times 7 instead of 4 times 6. Oh, look, that's an even number. That's 28. How about 10 times 3 instead of 10 times 2? That's 30. We're still getting an even. And that's going to continue. So an even times an odd is also still an even. All right, let's go over to odds. How about an odd times an even? Well, you may know that it doesn't matter what order you multiply numbers in. So odd times even is the same as even times odd. So this rule is going to still apply. We're still going to get an even number. And just do one example of 5 is odd times 6 is even. And we get 30, which is even. All right, one more we haven't tried yet is odd times odd. Will we finally get an odd number? Let's see. Odd 7 times an odd 3 is an odd 21. Yes, and that pattern is going to continue. We'll just do one more here. We'll do a 9 times a 5. 9 times 5 is 45. That's also odd. So odd times odd is odd. So one way you can remember the multiplication rules for odd and even is if even is involved, if an even number is involved in the multiplication anywhere, here, 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 the result is always even. So if an even number is involved, the result is even. The only way to get an odd number in multiplication is to multiply two odds. Now let's look at division. Now, at first glance, or sort of first thought, you might think the division rules are the same as the multiplication rules. But let's see if that's right. So I'll keep those multiplication rules up there just for comparison, and I'll write the division rules down here in another color. What happens if we divide an even number divided by, that's what that fraction line means, divided by another even number? Another way to write that is even divided by even. Well, let's try 12 even divided by 6 is even. We get 2, which is even. But what if we try 12, which is even, divided by 4, which is even? We get 3, which is odd. So right away, we can see that you could get either an even or an odd when you divide an even by an even. So even divided by even could be even or odd. All right, let's try even divided by odd. That's the next one here that we tried with multiplication. So let's try 12 divided by 3. Even divided by odd, we get even. Let's try 40 divided by 5. That's an even divided by an odd again, and we get an even. Let's try one more. 28 divided by 7. That's an even divided by an odd. We still get an even. So that's the rule there. You always do get an even number. All right, and then let's try odds divided by odds. What happens there? Let's try one. 21 divided by 7 is 3. Let's try another one. Let's do 45 divided by 9, two odd numbers. You get another odd, and the pattern is going to continue that way. So you always get an odd number. All right, now let's talk about something called factors. The factors of a number are numbers that divide into it evenly. So for example, what are the factors of 12? I'll just write the word factors up there first. So the factors of 12 are the numbers that divide evenly into 12. And those are 1, 2, 3, 4, 6, and 12. All those numbers divide evenly into 12. How about the factors of 20? The factors of 20 are 1, 2, 4, 5, and 10. Well, and 20. So factors of a number are what go into that number. Then there's also something called the multiples of a number, and that's what that number itself goes into. Okay, so if we think about it this way, let's take the number 6. The factors of 6 are what go into it, and those are 1, 2, 3, and 6. They divide into 6. Now we're talking about the multiples, which is what 6 goes into. 6 goes into itself, 12, 18, 24, etc. So 6 is a factor of all these, and its factors go into 6, and 6 is a factor of all its multiples. So these are the multiples of 6, and these are the factors of 6. So we could think of multiples as what the number divides into, or what it multiplies to when you're multiplying it by an integer. And the multiples are really just counting by that number. So remember when we said we're counting by consecutive multiples of 5, and we wrote down 5, 10, 15, 20. So when you count by multiples of 5, you are listing the multiples of that number, in this case 5. Another thing to notice is that there are infinite multiples of a number, always, because you can just keep multiplying forever. But there are always only certain number of factors of a number, so certain amount. And there is a way to find out how many factors any given number is going to have. So if you had some big number like 240, that's going to have quite a few factors. And you might want to know, did I get them all? Because here I just, for instance, listed the factors of 6 off the top of my head. For bigger numbers, that's harder because you don't necessarily know how many factors there are. But there's a cool method that you can use to figure out how many factors a number has. Let's look at that method. Okay, so this is how to tell how many factors a number is going to have. What you have to do is you have to get the prime factorization of that number. So a prime number is a number that is only divisible by 1 and itself. You could also say 1 and the number itself are the only factors. That's another way to say that. So for example, 7 is a prime number because the only numbers that divide into it are 1 and 7. 13 is another one. So how do we do a prime factorization of a number? Well, let's take the number 60. The way you do that is we're looking for all the prime numbers that go into 60, all the prime factors. So just start factoring it any way you want. 60, for instance, we know is 3 times 20. I could have started with 2 times 30. It'll lead to the same answer. So don't worry about which numbers you pick to multiply. Again, here I could say 4 times 5, or I could say 2 times 10. I'm going to say 2 times 10. And then 10 is 2 times 5. And now all I have at the end of my upside down tree here are prime numbers. So that's how I know I'm done and I've prime factored 60. Then what you want to do is you want to write this from the lowest numbers to the highest. So 2 is the lowest prime factor. 2 times 2 is 2 squared. And then it's just 1 3, so I could think of that as 3 to the 1 power. That's right there. And then there's 1 5. That's 5 to the 1 power. So that's the prime factorization. And the way you get the number of factors, because remember, prime factorization isn't the same as the number of factors. Because notice 20 is a factor of 60, but it's not here. 4 is another factor of 60, but it's also not showing up there, at least obviously. So the way you get the number of factors, you add 1 to each exponent. So 2 plus 1 is 3, 1 plus 1 is 2, 1 plus 1 is 2, and then you multiply those together. So 2 times 2 is 4 times 3 is 12. 60 has 12 factors. And if I just try to list them, I'm going to go 1. I'm going to do it this way. 1 times 60. Watch what I do. 2 times 30. 3 times 20. 4 times 15. 5 times 12. And now I've run out of room. 6 times 10. And now, by working in from both ends, you sort of squeeze in the possibilities. So the only other possibilities left are 7, 8, and 9. And none of those go into 60. And anyway, I already see my 12 factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a great little trick. Okay, let's talk a little bit more about prime numbers. And let's first start down with the number 1. 1 is kind of interesting because we've said a prime number is only divisible by itself, by 1 and itself. So if you think of that as requiring 2 factors, 1 and a different number besides 1, then by that definition, 1 is not prime. Because it's divisible by 1, but not some other number. So 1 is not considered prime. 2 fits the definition because it's divisible by 1, and the only other number is 2. But notice that no other even number is prime. Because, well, let's start with 3. 3 is prime. Only 1 and 3 go into it. Once we get to the next even number, 2 will go into it. So immediately there's another number besides 1 and the number. So the only even number that's prime is 2. Every other prime number is odd, and 1 is not prime. And let's list the prime numbers that are less than 100. It's a good idea to just be able to recognize as much as you can when you're looking at a prime number, since they're kind of special numbers. So let's list them. Starting with 2, that's the lowest prime. 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So you might just kind of want to take a mental snapshot of those numbers. It's just good to know what's prime. Or maybe you could start with just, the first, say, 10 or so prime numbers up to maybe 23. All right, let's move on to something called a lowest common multiple. And that's often abbreviated LCM. So, lowest common multiple. We've talked about what a multiple is. It's what a number multiplies to. And now we're looking at what two or more numbers have in common as a multiple. So, for example, if I took the numbers 2 and 5, well, they both go into the number 10. 2 goes in 5 times, and 5 goes in 2 times. So for 2 and 5, 10 is the lowest common multiple. They also both go into 20, so that's a common multiple, but it's not the lowest common multiple. So lots of times we are interested in the lowest common multiple of two numbers. There's different ways you can get it. Sometimes you can just sort of think about it, but there is a good methodical method that I'm going to show you now, and it has to do with prime numbers and prime factorization. Before I show you that, though, let's just talk about, or just look at maybe one more example. So let's take the numbers 7 and 4. Well, 7 times 8 is 56, and 4 times 14 is 56. Whoops. So that's a common multiple, but the lowest common multiple for 7 and 4 is 28. Okay, now let's look at this method that will get you that lowest common multiple every time. Let's look at the numbers 180 and 240. So, pretty big numbers. It's not immediately obvious what's the lowest number they both go into. So, here's how you can do that. Prime factor each number. So, I'm just going to do that here. 18 times 10, 9 times 2, 3 times 3. Remember, it doesn't matter how you factor it because you're always going to end up at the primes. So these are all prime numbers now. And that means the prime factorization of 180 is going to be 2 to the second power, because there's 2 of them, times 3 to the second power, because there's 2 of those, times 5. So I've written the prime factorization of 180 as primes to a power. Now let's do the same thing for 240. I'll start with 24 times 10, and I'll go with 8 times 3, 4 times 2, and 2 times 2 there. And over here I'll go 5 times 2. And again, I've ended up at primes. Can't go any farther. Okay, so I have 4 2s, 1, 2, 3, 4. That's 2 to the 4th power. I have 1 3 and 1 5. So you write each number with prime factorization with their powers. Now I'm going to rewrite those up here. 180 is 2 to the second times 3 squared times 5. 240 is 2 to the 4th times 3 times 5. Now what you want to do is you want to look for any primes that they have in common. So we'll start with 2. They both have the prime factor of 2, but you have to take whatever the 2 is, whatever the power of 2 is higher. So I have to take this, because 4 is higher than 2, to make my LCM. So I have 2 to the 4th. Now the next prime factor they have in common is 3, but this time 3 to the second is the higher power. So I'm going to pull that one down. And then with the 5 they have in common, well, that's a tie. They're both 5 to the 1, so you just take one of those. It doesn't matter which one. And that multiplied together is going to be the LCM of 180 and 240. So that's going to be 16 times 9 times 5. And that happens to equal 720. Okay, so that's how you get the LCM of any two numbers. Now let's talk about a method for finding the greatest common factor of two numbers. And that's often abbreviated as the GCF. So now we're not looking for the lowest thing the two numbers themselves multiply to. We're looking for the largest number that divides into those two numbers. So for example, if we took the numbers 8 and 12, the biggest number that goes into both is 4. So 4 would be the greatest common factor of 8 and 12. Now again, with larger numbers, it isn't always easy to figure that out at first glance. So I've left 180 and 240 up because when you're looking for the GCF, you actually want to prime factor the two numbers also. So we are going to want 180 and 240 in their prime factorization. So I'll just rewrite that up here. We said 180 was 2 squared times 3 squared times 5. And 240 is 2 to the 4th times 3 times 5. This time, you're kind of doing the opposite. Now you're taking only what they both have in common. So now you're looking for the lowest power of any shared prime factor. So they both share a 2, but they only have up to 2 squared in common. So now I'm going to pull down the 2 squared. They both have a 3, but they only share up to one of those. So again, I'm taking the lowest power. And then they both share a 5, so we're going to pull the 5 down. All right, so 2 squared is 4 times 3 times 5, and that's equal to 60. So 60 is the largest number that will divide into both 180 and 240, otherwise known as the GCF. And here's something really cool. If you multiply any two numbers together, so let's do these two numbers, that will be the same as if you multiply their LCM by their GCF. So remember, the LCM of 180 and 240 was 720. So here's the LCM. This is the GCF. So 180 times 240 will be equal to 60 times 720. They're both equal to 43,200 if you want to try that. So let's write out that rule and then just do a example with two smaller numbers. So we can say if the LCM of two numbers x and y is p, and the GCF of the same two numbers of x and y is q, then x times y will equal p times q. So let's take the numbers 12 and 18. The lowest common multiple is going to be 36. The greatest common factor is going to be 6. And 12 times 18 is 216, and so is 36 times 6. 216. Another good thing to know is that the greatest common factor of any two consecutive numbers will always be 1. They can never have any primes in common. So the GCF of two consecutive numbers is 1. So just take any numbers, 59, 60. They cannot have any common factors except for 1. Now let's take a look at a formula for when you divide two numbers and get a remainder. So we're going to be looking at, I have some number x divided by some number y. The answer is going to be what we call the quotient. How many times y goes into x, plus any remainder divided by y, the thing on the bottom. So for example, if I had 37 divided by 8, I could write this as 32 plus 5 with an 8 on the bottom. And then I picked 32 because 8 goes into 32, right? 32 over 8 plus the rest of the fraction. So 8 goes into 32 4 times. That's the quotient. That's how many times the bottom goes into the top. In this case, 4. And there's 5 left over. So that's what we call the remainder. And you just put that over that denominator of the fraction. Okay, so your formula for that is up here. And remember that this remainder, it has to be a non-negative number, so 0 or positive, but it has to be less than the divisor. The divisor is what you're dividing by, so in this case 8. It's the number on the bottom. So notice, if it were as big as 8, let's just say you had mistakenly gotten 4 plus 8 over 8. Well, that's 4 plus 1, which is 5. So there no longer is a remainder, or the remainder is 0, we could say. So let's just say with 37 over 8, let's say we had mistakenly picked 24 as what we wanted 8 to go in. And then we would have gotten plus 13. And then we would have gotten 24 over 8 plus 13 over 8, which is 3 plus, but 8 goes into 13 another time. So that's 1, and then the remainder of 5. So this number, that remainder, needs to be a positive number or a non-negative number less than the divisor. Okay, last thing we're going to talk about in this video is just how trailing zeros are related to the factor pairs. Let's take a look at what I mean by that. So a trailing zero is just a 0 at the end of a number. So let's say 640. That's one trailing 0. Now 640 is equal to 64 times 10. And there is a pair, a 2 times 5 prime pair hiding in that 10. So there is one 2 times 5 pair corresponding to 1 0. And if we added a 0 to that number, now we have 6,400 or 6,400. That's 64 times 100, and 100 is 10 squared. And we know that 10 is 2 times 5. So notice now we have 2 pairs of 2 times 5 corresponding to 2 trailing zeros. So the number of 2 times 5 pairs is equal to the number of trailing zeros. All right. Hope that lesson was helpful, and I'll see you in the next one.